Let's have a 4-inch overhang. Now we have all the physical entities. Let's select them and create a group. Let's set the type of the group to differential drive. Next, let's configure the wheel axle. We'll set the initial power of the wheels. Left will be 0.3 and the right will be 0.2. Now export and run the simulation. As you can see, we now have the physical representation of our drive initialized. The drive will run in clockwise circles because we gave the left wheel more power. We could create a mesh for the drive, but I won't do it here. AR comes with a number of sensors. Let's add one, say a camera, to the end of the rotating arm. Let's set the camera mass to a small value, say 0.1 kilograms, and attach it using a fixed joint. AR allows you to build and group components. You can assemble these components with other components to build larger components, which in turn be assembled into still larger components. You have no limits to the number of levels. Let's group all the components of the robot arm. We need to set the base entity to dynamic so it can move. Also, we need to set it as attachable, the entity that gets attached when you attach the component to another component. Now we'll add a fixed joint, so the capsule doesn't move relative to the base. At this point, the robot arm is a component that is ready to be attached to other components. Now let's quickly build a room. AR is integrated with Google 3D Warehouse. 3D Warehouse has literally millions of models that you can easily insert into your simulations. Japan alone has over 14,000 buildings modeled, and there are over 100 million mechanical parts. Let's say you want to design a robot that can avoid office furniture in a room. AR makes this fast and easy. Let's get some office furniture from 3D Warehouse. Let's just get a table. A search on table produces about 14,000 models. Let's download one and place it in the model. Now let's place the differential drive in the room and mount our robotic arm on top and attach it. Next, attach the arm component to the differential drive. Now let's group everything together to make our robot. Building swarms of robots is easy. Let's create 3 robots that are identical and orient one of them into a different direction. Now let's export and run the simulator. By distributing AR as a DLL, you can write code to modify or remove any entity that you exported from SketchUp. You can also write code to add new entities if you want. This way AR doesn't limit your simulations, and you always have full control over them. As you can see, it is easy to build sophisticated simulations, both the robots and the scenes that they live in. Imagine how long it would take to do this by writing code. In this introductory video, I have just touched on the capabilities of AR. You can create your robot simulations visually in hours instead of days or weeks writing code or scripts. There is nothing available on any platform to build and test your robotic prototype so quickly and easily. The beta version of AR Express is available now for the first 50 beta users, and you can download it once you register. We are limiting it to 50 users to ensure that as we approach release, beta users have the best possible experience with it. When released, AR Express will be free. Please check out the learning page on this site for more examples, and thanks for watching.